we're going to be working with some column vectors for this question. So we've got A has the definition of 2 and 0, B equals 3 and 5, C equals -1 and -2. Remember, vectors are written so that the horizontal movement is the top number and the vertical movement is the bottom number. So we need to work out A plus B, which is the resultant vector from those two vectors being combined. So our first step will be to substitute those vectors in their places. Then the second step would be however you want to imagine this happening, we're going to scale up the vectors depending on the number outside. Now in these two examples, or in this example, we have a 1 in front of the A and 1 in front of the B, which means there's a 1 in front of those brackets. But we don't really need to scale these vectors up, but there's that little bit of knowledge that you need to have when you do have to scale these up. Right? So we scale up the vectors if we have to. Third step is then to simplify. To simplify, we're just going to add the top number together and the bottom number together to get 5 and 5. That is the resultant vector when we add the column vectors A and B together. Now if we were looking at that sort of in a diagram, then vector A, we're starting from that point, is 2 across only because there's no vertical movement. So we go 2 to the right because it's a positive 2. From there we add on the vector B, which is 3 to the right and 5 up. So we go 3 to the right and then 5 up. So where that ends, that's the vector we're interested in, the vector being the diagonal line. And if we look, that vector is in its finished state is 5 across and 5 up, which is what we got from adding the two vectors together. So that's the resultant vector. For the second example, 2b, this is an example for scaling. So we substitute, we've got 2 and then the vector b goes in there, and now we scale up the vector. We start by substituting and we scale these up. So 2 times 3 is 6 and 2 times 5 is 10. So that's our vector. Now we can see this happen on a diagram. It's always good to visualize what's happening so you can understand. There's no simplifying in this question, by the way, because there's nothing to simplify. So if we start here at this x, then we have 2 vector b's that need to be put together. So we're going to go 3 across, 5 squares up. So that's vector b. That's one vector b. Right, but we're looking for 2 vector b's together. So that's going to be double the length. Right, so that's one vector b along with another. So the resultant vector is 2b, and the resultant vector is going to be double what vector b was originally. So it's going to be 6 and 10. Right. Now for the third example, we're going to substitute, because we're putting together 2 vectors, A and C, but it's going to be scaled up versions of those 2 vectors. So the resultant vector is going to be a scaled up version of this. So we get 6 and 0 plus -2 and -4. Right. So we're going to put these 2 vectors together. We're going to simplify now. 6 plus -2 is going to be 4, and 0 plus -4 is -4. So that's our resultant vector. Now if we look at this visually, this is an interesting one to kind of visualize. So we start there, and we're going to go with 3 vector A's. So one vector A is 2 across, another vector A is 2 across, and another is 2 across, which ends up being 6 across only, which is what we got in the blue step. Then we need to add on 2 vector C's. So we're going to go -1 across, -2 down, -1, -2. Where we finish up, that's the resultant vector that we're interested in. So if we join that line from the original x, that vector is what we are interested in. And if we were to just confirm what that vector is, we will see we're going 4 across and then -4 down. So our resultant vector mathematically is correct. and also in the diagram form so it matches up.